In this video, we're going to look at how to graph sine and cosines with phase shifts. Now recall for the parabola y equals x squared, it's going to look like this graph that's shown below. Let's look at how it's related to the equation y equals the quantity x minus 2 squared. What is the transformation here? This is going to be a horizontal shift of 2 units to the right. We take all the points from the original parent function y equals x squared, and we're going to move them 2 units to the right. So it's going to look like this. In general, anytime you have a function f of x, y equals f of the quantity x minus h is going to be a horizontal shift. And in particular, with the parentheses, if you see x minus a number, that's going to tell us that in this case we're going to move h units to the right. And this is any time h is greater than 0. If you have that positive number substituted in, you're going to get x minus something. And that's going to tell you a horizontal shift to the right. Now, if you substitute a negative number in for h, x minus a negative becomes x plus, in which case you get h units to the left if h is less than 0. Now let's look at the parent graphs for sine and cosine. They're shown below. Recall that y equals sine of x is going to start at center and then go from center to max to center to min to center. It's going to have an amplitude of 1 and a period of 2 pi. Now y equals cosine of x is going to have the same amplitude of 1 and period of 2 pi. However, it's going to start at max and then go from max to center to min to center to max. Well, let's try something with the phase shift. Let's take and try graphing y equals the sine of the quantity x plus pi over 2. In order to do this, we first need to figure out what is the horizontal or phase shift. If we take the parent function y equals sine of x and look at it in comparison to the new equation y equals the sine of the quantity x plus pi over 2, it's x plus, which tells me we have a negative h value. In this case, we're shifting to the left pi over 2 units. So we're going to go ahead and sketch y equals sine of x plus pi over 2, but we're not going to start at 0, 0. If instead of starting at 0, 0, this graph is shifted to the left pi over 2 units, our new starting point is going to be negative pi over 2, 0. Since the frequency of this graph is 1, it is a 1x, the period is going to be standard. 2 pi divided by 1 tells me that the period is going to be 2 pi. Now normally a sine graph would do a complete cycle between 0 to 2 pi. However, this graph is going to start pi over 2 to the left, which means it's going to end pi over 2 early. So this will complete a full cycle a little bit earlier. Let's figure out where it's going to be. Now I've got a graph scaled out, and the way I did this is I know that the period is 2 pi, which means I need to have 4 ticks to get a complete cycle. So if the full cycle is 2 pi, a half cycle would be pi, which is my second tick, and then half of that, half of 1 pi would be pi over 2. Each of my ticks, or each quarter cycle, is going to be pi over 2. And then I can just start counting by pi over 2s. 1 pi over 2, 2 pi over 2, which is a pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, and so on. To the left, I put my negative pi over 2 and negative pi. So let's go ahead and start graphing. We said that the sine is going to start at negative pi over 2, 0. It's going to start at center. But the center has been shifted to the left pi over 2 units. From that point, we're going to graph what sine normally does. Sine goes from center to max to center to min to center. And that's going to be one complete cycle. Let's graph it. So instead of taking all the way to 2 pi to finish, it's going to finish at 3 pi over 2. Now keep in mind, negative pi over 2 to 3 pi over 2 is a period of 2 pi. Now let's extend it just a little further. Let's take it to 2 pi comma 1. Let's go one more tick. That would put us here. What do you notice? Look at this graph. If I look at the piece in red, and I didn't know any better, I would say this is actually a cosine graph. If I didn't know that we had phase shifted to the left, I would have thought perhaps that we had graphed a cosine graph. This looks like a cosine function. On the y-axis, it appears to be starting at max and then going center, min, center, max. It almost looks like a cosine graph. And it turns out, really, y equals cosine of x is just a phase shift of y equals sine of x. Any cosine can be a phase shift of sine, just like any sine can be a phase shift of cosine. It's just moved to the left or to the right. Now in this case, y equals cosine of x is the sine graph shifted pi over 2 units to the left. Because we took the original sine graph and moved it to the left, it appears to be cosine. Now let's take a look at another equation here. Here we have y equals sine of the quantity 2x minus pi over 2. At first glance, you might think this is a horizontal shift of pi over 2, but it's not. And it has to do with the frequency here. Okay, the coefficient of x must be 1 before you can determine what that horizontal shift is going to be. In this case, because we have a 2x, it's not going to be the negative pi over 2 that it appears to be. Now, if you remember the standard form of a sinusoid, it's going to look like one of these, depending on whether it's sine or cosine. Notice that the frequency, or the b value, has been factored out inside that argument, inside the brackets. If the b value is factored out, then we can see what that actual shift is going to be. But in the example above, it hasn't been factored out, which means the shift is not negative pi over 2. It's not positive pi over 2 either. Okay, so there's two strategies for how to find the horizontal shift if you've got this frequency other than 1. The first technique we can do is factoring out the coefficient. Whatever the coefficient of x is, we can factor it out of that argument, and that'll show us what the actual shift is. The second way we can do it is to set the argument, or the piece inside the parentheses, equal to 0, and solve for x. This is going to help us to find the new starting point for our graph. Now, if we look at the example up top, we're going to look at how to do this both ways. Let's start with the factoring. The coefficient of x is a 2, so I'm going to factor a 2 out of everything that's in the parentheses. I'll take 2x and divide it by 2, and I'll take negative pi over 2 and divide it by 2. This is going to give me, instead of y equals sine of the quantity 2x minus pi over 2, if we factor out the 2, I'm going to get y equals sine of the quantity 2 times the quantity x minus pi over 4. Now you can check real quick to make sure this is correctly factored. It's a little tough to do when you have fractions sometimes, but if you think of distribution, if I look at that bottom equation and was to distribute the 2 into the parentheses, 2 times x would give me the 2x that I have above, and 2 times negative pi over 4 would be negative 2 pi fourths, which is negative pi over 2. So I could see that distributing this, I would get the equation above. So this is correctly factored. In this form, I can now actually see what the shift is. I have a 1x minus pi over 4, which tells me this has actually been shifted to the right, pi over 4. Now another way to do it, like I mentioned just a moment ago, is to set the argument equal to 0. Take the 2x minus pi over 2 and set it equal to 0. You then solve for x. To solve for x, or isolate the variable, I would want to add pi over 2 to the other side, and then divide by 2. Now I don't like dividing fractions, so instead I'm going to multiply by the reciprocal. So instead of dividing both sides by 2, I could also multiply both sides by 1/2. To me, this is a little bit easier. On the left side, I'm going to get just an x. On the right side, I'd have pi over 2 times 1/2, which means multiplying the numerators, pi times 1 is just 1 pi, and the denominators, 2 times 2 is 4. This is going to give me pi over 4 again. Now when I solve it, this tells me that x equals positive pi over 4 is the new starting point. And that would be to the right because that's where the positive numbers are. So both of these give me the same shift of to the right pi over 4. So as we do the other problems, again, I'll show you both methods. All right, so let's graph another one with a phase shift. Here we've got f of x equals 6 sine of the quantity 4 times the quantity x minus pi over 8. Take a moment and see if you can figure out what is the amplitude, the period, the horizontal shift, and the vertical shift. Well, the amplitude is 6. To find the period, we need the frequency. In this case, the frequency is 4, which tells me that 2 pi divided by 4 is going to give me a period of pi over 2. There is no vertical shift. There's nothing added outside of the parentheses for the sine. And the horizontal shift, let's look, is it in factored form? Can we just look at it and know what it is? And the answer is yes. The 4 has been factored out, which means I can see that the horizontal shift is going to be the pi over 8. Now I could also solve it by setting the argument equal to 0. If I took x minus pi over 8 equal to 0, add pi over 8 to both sides, I could see that the shift would be to the right, pi over 8. Now I usually put a little arrow down below just to kind of remind myself that, positive numbers have to go to the right, negative numbers are to the left. Or I look in the parentheses and I see that x minus h, right? It is in the form x minus h, which means h is the pi over 8. It is a shift to the right, pi over 8. Now, if we're going to scale the graph, I don't need any room to the left because we are shifting to the right. So I can have my y-axis tight to the left-hand side. And I'm going to give myself 8 ticks to the right. 8 ticks to the right will guarantee 2 full cycles. Now, as far as scaling, if the period is pi over 2, then the fourth tick, a complete cycle, needs to be pi over 2. A half cycle would be half of pi over 2, which is a quarter of pi, and then half of a quarter would be an eighth. That means each tick mark is going to be 1 pi over 8. Vertically, I need to scale from 6 to negative 6. Right? There is no vertical shift, so we just need the amplitude up and down. So 6 and negative 6. All right, let's start graphing it. Now, this is a sine graph, but it's phase shifted. Instead of starting at 0, 0 and calling that center, we're going to move to the right pi over 8. So we're going to go over to pi over 8, 0, and that's going to be my new starting point, or the center for this sine graph. And then from that point, we do what sine typically does. Sine goes from center to max to center to min to center, and that's one complete cycle. Now, I could go further and go from center up to max to center to min. Now, I haven't done a full 2 cycles yet because I've run out of room. I could add another tick mark, or I could just take it back to the y-axis. If going backwards, let's go like from pi over 4, we're at max. If we went to pi over 8, that's center. If we went to where x is 0, that means I'd be at the minimum. And now I can graph it knowing that I have 2 full cycles because I've got, if you look at it, it almost looks like a negative cosine graph. It's starting at minimum. There's another minimum at pi over 2, and there's another minimum at pi, which means, yes, I have gone 2 full cycles. Now, keep in mind that when you do a phase shift, the graph may not look like what you initially think, right? If I'm seeing a sine graph is what I'm supposed to be graphing, but what I call maybe the apparent graph, what it appears to be if I didn't know any better, it actually looks like a negative cosine graph. Now, what I'm going to usually do, so I remember what graph I did, I'm going to highlight where I started. I'm going to go 1 full cycle, starting at that pi over 8 phase shift. If I highlight it like this, I can see, yes, it actually is a sine graph, but it's been moved to the right pi over 8 units. All right, why don't you go and try this one? I'm going to let you work it out. Go ahead and pause the video, and then resume the video when you're ready to check. I'll give you a moment. All right, hopefully you've had a chance to work this one out. The amplitude is 3. The frequency is 1/2. 2 pi divided by 1/2 becomes 2 pi times 2, which is going to be 4 pi. If it's half as fast, it takes twice as long to finish. No vertical shift. This time, though, the x over 2 plus pi needs to be factored out. If I divide by half, I would get half times the quantity x plus 2 pi. Or, if I solve it, I can get x over 2 plus pi equals 0, subtract pi from both sides, multiply both sides by 2, and you'll get the same answer of x equals negative 2 pi. We're shifting to the left negative 2 pi. Because we're shifting to the left, I need to actually have some room on the left. Now, if the period is 4 pi, half of 4 pi is 2 pi, which means a half cycle is where I'm going to start. So I've got my scaling. Now, this one is a negative cosine, which means you're going to start at minimum. The minimum is going to start at that negative 2 pi for x. So here's our minimum, and then it does what negative cosine does. From minimum, center, max, center, min, there's 1 complete cycle. Center, max, center, min. If I go to 6 pi, I've done 2 full cycles. Now, this ends up looking like a positive cosine graph in the apparent way. However, if I highlight starting at that negative 2 pi, 1 complete cycle, I'll see that it was negative cosine, but shifted to the side. Now, the last thing we're going to look at is how we can take a graph, in this case it appears to be sine, but we can actually look at it 4 different ways. We can look at it as a sine, cosine, and negative cosine. And that other ones can be done with phase shifts. Now here, the amplitude is 1. The period is 2 pi, which means the frequency is also 1. So the apparent graph that I see, without any shifts, would just be y equals sine of x. Or if we write it as a function, f of x equals sine of x. Now let's phase shift it. If I want to catch it as a positive cosine, I just need to move somewhere where we have a maximum value. That would be to the right, pi over 2. The function would then be f of x equals cosine of x minus pi over 2 if we're shifting to the right. Now there are other answers that are possible. A negative sign would have to be at the minimum. So a minimum might be something over here. How about negative pi? If I say start negative pi, that's center to min, and that's going to be a negative sine graph. This function would then be f of x equals negative sine of x plus pi because I've shifted to the left pi units. Where would you see a negative cosine? I could do that one starting maybe here at negative pi over 2. That would give me f of x equals negative cosine of the quantity x plus pi over 2 because we've shifted to the left. All right, thank you for watching.